Section 14E, question number 5, page 357. Question number 5 asks us to use first principles, the first principle formula, to find the gradient of the tangent to a variety of functions. The first one being f of x equals 3x plus 5 at x equals negative 2. So we use the same technique as we did in question number 4. So we'll find f prime of negative 2 in this case. And we use the limit definition of the derivative, which is from first principles. And so I'll just substitute in, instead of a plus h, or x plus h, like we had in the past in the general case, I'm going to substitute in negative 2 plus h in for x in the first part. And we subtract negative, or minus 3, and then substitute in negative 2 for x, plus 5. And that's all over x plus h minus x, which just gives us h. So I'll do a little bit of expanding and simplifying then. So I multiply here, I get negative 6 plus 3h plus 5, and then I'll expand this in, I get negative 6 here, multiplied by that negative, so you get plus 6, and then that gives us negative 5 here. And then negative 6 plus 6 get cancelled out, 5 minus 5 gives us 0 also. So we're left with the limit of 3h over h as h approaches 0. The h's can simplify down, so we're left with the limit of 3 as h approaches 0. Therefore, f prime of negative 2, or the gradient of this function at x equals negative 2 is 3. Now we move on to b. Question b, the function is 5 minus 2x squared, and this we're evaluating at x equals 3. So f prime of 3 is the limit of 5 minus 2, and then 3 plus h squared, that 3 plus h gets substituted in for x, minus 5 minus 2 quantity 3 squared, all over h, as h approaches 0. Now we'll do a little bit of expanding here. I'll leave this negative 2 out front here for now. 3 squared plus 2 times 3h plus h squared. And then I'll just multiply this negative 1 into the bracket. Negative 5 plus 2 times 3 squared, all over h as h approaches 0. Again, the limit 5 minus 2 times 3 squared minus 4 times 3h minus 2h squared minus 5 plus 2 times 3 squared, all over h as h approaches 0. Now I've left it in this form here without multiplying through, because some of these things are just going to cancel out. So if I'm really stuck and I don't know what some of these things are mentally, using mental math, I know that they're just going to cancel out anyways. So why put myself through all that torture and calculate these out, even though I could do it if I wish, but there is another way of going about that. Why do the work you don't need to, is what some people would argue. And so then we get here, and because we've got the h's here, I'm just going to factor out the h right from the beginning. So h gets factored out, so we're left with negative 4 times 3 minus 2h all over h. The h's will cancel, and it's the limit as h approaches 0. Again, the limit as h approaches 0, and now I can multiply this negative 12 minus 2h When I now substitute 0 in for h, we're left with just negative 12, so the gradient of this function, when evaluated at x equals 3, is negative 12. And in question 5c, we are finding the gradient of the tangent to this function x squared plus 3x minus 4 at x equals 3. So we follow the same process. F prime of 3 is the limit, and then I'll substitute in 3 plus h for x, and square that, plus 3 times 3 plus h, minus 4, minus 3 squared, plus 3 times 3, minus 4, all over h. And I'll do all that simplification. No, sorry. So that's limit of all that as h approaches 0, of course. Same sort of routine. And I will do this expansion. So this 3 squared comes from 3 times 3, plus 3h here, minus 4, and then minus 3 squared, minus, and there's another 3 squared, and then plus 4. All over h. 3 squared cancels with negative 3 squared. This 3 squared cancels with that negative 3 squared. Negative 4 cancels with positive 4. And then we'll just clear that up a little bit. So we get 2 times 3h plus h squared plus 3h all over h as h approaches 0. The limit, and I'll factor out the h here, 2 times 3 plus h plus 3 all over h as h approaches 0. So these h's will cancel out. We're now left with 6 plus 3, 9 plus h as h approaches 0. Therefore, the gradient of this function at x equals 3 equals 9. And now part D. It's got a little different look to it, but we're going to use the function 5 minus 2x minus 3x squared and evaluate the gradient of that function at x equals negative 2. And again, we're using the limit. So we do 5 minus 2 times negative 2 plus h minus 3 quantity negative 2 plus h squared minus 5 minus 2 quantity negative 2 minus 3 negative 2 squared all over h. And that limit is, of course, as h approaches 0. Now we'll do some expansion. 5 plus 4 minus 2h minus 3 times negative 2 squared plus 2 times negative 2h plus h squared minus 5. Here's plus 4. Or actually, maybe I'll just do the plus 2 times negative 2. Keep it in that form. Plus 3 times negative 2 squared. All over h again as h approaches 0. And then I'll do a little bit more simplification here as I bring in this negative 3 into this bracket. And then the fun begins when we get to cancel things out. So 5 minus 5, here's a 0 pair, positive 4 minus 4, negative 3 times negative 2 squared, and positive 3 times negative 2 squared, another 0 pair. And then we've got finally negative 2h minus 6 times negative 2h minus 3h squared all over h. Again, factoring out an h. Negative 2 plus 12 minus 3h all over h. H's cancel. So we're left with 10 minus 3h. Therefore, f prime of negative 2, when we substitute 0 in for h, equals 10.